So we're going to do a couple of definitions first. So a conic section.
Could you make it full screen?
Yeah. Okay. A conic section is a figure formed by the intersection of a plane and a right circular cone. And if you're just like, what the heck? I have 4 beautiful examples. Those are the way we tilt that plane creates the 4 conic sections that we are talking about. We will not be talking about hyperbola this year due to the corona, but we're going to focus on circle, ellipse, and parabola. Today's lesson is just about this parabola right here that is formed by that plane. Okay, one thing about conic sections that are nice is that they're very useful. The headlights in your car are actually formed with these parabola conic sections because they were able to figure out what point will that light bulb go to give you the best light from your car. Isn't that neat? They just found the focus point. So to keep going with this, parabolas as a conic section. A parabola is a set of all points that are equidistant. I don't really know. Let me spell it right.
Yeah, equidistance. One word, like weird.
Yeah, it's a weird word. That just means that they're equidistance is kind of like just what it is, to a point called the focus point of the parabola and a line which we are calling the directrix. Fancy words we got going here. So what the heck does all of this mean? So here's the parabola you know and love, you've learned about, all that fun stuff. So what is going to happen is we have a focus point on the inside of the parabola. So this is what we call the focus point.
Is it always at that one spot?
No, it depends on how fat the parabola is. It depends on how skinny it is. It depends on which way it's flipped. But it's always on the inside. It's never on the outside. Okay?
Okay.
Makes sense.
I'm sorry. Focus point. So that's where the focus point is. Well, there's a lot of math to help us find the focus point. And then we have, so that's the focus point, but they also talk about the line, which is called the directrix. So when a parabola is facing up or down, we're going to have a line, a y equals line. And this guy is called the directrix, and it's on the outside. It's never going to split your parabola. Sometimes it's x equals, depending on which way this parabola is facing. So we have parabolas up and down, but we also have parabolas left and right, too, when we're talking about conics. Now, there is some math here. This right here is always p away. And then this right here is also always p away. That's the distance it is from the vertex, this value p. And it's going to make more sense once I fill out this table. Where do you even get p? It's really easy. And then there's some other things about this. So here, this is what we call this dashed purple line is the focal width. And it's 2p on each side. So if it were together, it would actually be 4p for the focal width. Okay? And then, yeah, that's kind of is. Definitions before I jumped into this. So now we're going to talk about, so I'm going to do one type of parabola first. So y equals a parentheses x minus h squared plus k. Hopefully that looks familiar. You learned that in math 2, probably talked about it in math 3. But that's the vertex form of a regular facing parabola, up or down, depending on what value that A is. So if it's a positive A, it's going to be facing up. If it's a negative A, it's going to be facing down. Okay? And then the vertex, remember, is the opposite of H, comma, K. And I always say the opposite of H because in our formula, it's a minus sign. So when we pull it out of the formula, we have to take the opposite value of H. And then the focal width, which is what I talked about, is for P. But where does that value come from? That comes from, we get that number, where we can find P is based on the A value in vertex form. So it's the absolute value of A equals, so the absolute value of A equals 1 over 4P. So if you were to get it by itself, though, that just means 4P equals 1 over the absolute value of A. And then, of course, if you're just trying to get P, you would have to divide. And then we have the focus point. So if we look at this picture up here, my focus point is above the vertex. So which value is changing when I go above the vertex? Is the H value changing or the K value changing?
K.
The K value, that Y. So it's going to, when you talk about the focus point, it's either going to be H, and then we have K plus or minus P, depending on which way that parabola is opening. If it's opening down, then we would subtract P. If it's opening up, we would add P, okay? And then the directrix for this kind of parabola is always going to be, it's a Y equals line. And all it is going to be the opposite of whatever you did here. So it's still K plus or minus P. It's the Y value because it's Y equals, but it's going to be different from the focus. So if I added to get the focus, then I'm going to subtract to get the directrix. Okay, so they are, it just depends on which way it's opening, that plus or minus. Okay, it's going to make way more sense when you get examples, I promise. All right, well, that's a regular. This new-ish type where you're like, but it's not a function. It's still a conic section, though. So it's x equals a. And typically, we would say x minus h, but this time we're going to say y, and instead of h, we're going to subtract k, because k is always with the y value. And then I'm going to add h this time. Yeah, so if A is positive, my graph looks like this. And my focus point would be in the inside and my line would be over here. So that's if A is positive. If A is negative, it's going to be the other way around. And my focus point is over here. And my directrix is over there. And this is if A is negative. Then the vertex, you have to be super careful with this because they try to trick you. This is probably one of the most missed problems, is that you're so used to pulling out H comma K, but now they're backwards. So when you're writing your vertex, H is going to be on the outside. That's going to be the H value. And now you're going to take the opposite of K because it's the one that has the minus sign in the formula. So that's just, you have to be careful when it's x equals. And then guess what, guys? The focal width is the exact same way. So I'm not going to rewrite it. These are the same way. You find the focal width the exact same way. The focus point, however, is going to be a little different. What value is changing now if I'm going left and right?
H.
Yes. And we're still moving it, that P value. Okay. And then the directrix, this time though, look at this line. It's going up and down. It's a vertical line. And we know that when we write vertical lines, it's not y equals, it's
X equals.
Yes. And since we're using the x value, we're going to use the x value of the vertex. So again, it's opposite of whatever you did to find the focus point. So if I added to find the focus point, then I'm going to subtract to find the directrix. If I subtracted to find the focus point, I'm going to add to find the directrix. It's a lot of information. The more this, everybody says how hard this is, but the more you practice, the more you'll get this.
Find the vertex, okay, and the focal width, the focus, and the directrix. Those 4 things Ms. Willis was just explaining to us. So to begin, I like to always solve for the single variable first. So what do I mean by the single variable? The variable that only has 1 as its exponent. So in other words, we have this x squared that doesn't have a 1 as an exponent, it has a 2. But we also have y. Well, y is our single variable, so we're going to solve for y. Okay, so in this case, this is going to be y equals x squared divided by 8, or you can think of it as y equals 1/8 x squared. And this is therefore our equation. All right, now when we think about equations, this is a y, a y equation. And so we know it's going to open up or down. And since A is positive, we know it's going to open up. Opening up. And now we just want to figure out some more information from this. So this is, in other words, my step 1. Step 2 is to find the actual vertex. So our vertex, since we have solved for the single variable, which is y, it's now in vertex form, h comma k. Well, you know, with parabolas, x plus or minus h squared plus k. Well, we only have x squared and we have 1/8 in front of it. So there's literally no minus h. There is no plus k. So when there's neither of those, then that means h is 0 and k is 0. And so that is our vertex. So that just lets us know that if I were to add lines to this in terms of an axis, a y-axis and an x-axis, our vertex is at 0, 0. Okay? Boom, boom. So we just sketched the quick little graph. Now we're just adding the actual details to it. Okay, step number 3 is to find the focal width. I'm going to abbreviate that, FW, and my handwriting looks terrible. Anyways, so the formula that Miss Willis gave us was that we're going to have the absolute value of A equals 1/4P. All right, now that we have solved for Y, single variable by itself, we know that A is 1/8. If it was a negative 1/8, A would still be 1/8 because we want the absolute value. And that equals 1/4P. And now we can solve essentially for P, or we can think of it as solving for the 4P. So either we're going to solve for P, figure out what that is, or we can solve for 4P. We're going to literally solve for both of those though, because knowing the 4P lets us know the entire width versus we still need the single P as well. Okay, so let's solve for it. Well, as we notice, a shortcut way of thinking of it is, well, our numerators are equal, so then that means our denominators are equal as well. So 4P equals 8. That is the quickest way to know exactly what 4P is. And remember, the 4P comes from the parabola that Mr. Willis was telling us about up at the top, the width, because the width over here is 2P and the width over here is 2P. So the width in all is 4P. So whatever 4P is, which in this terms 4P is 8, then that is our width. All right. Let's take a little bit of that stuff off. Boop. Okay, so 4P here is 8. And I'm going to, I like writing it to left to right. I don't know. This is just me. And this is your focal width. Ta-da! And so that's our focal width versus up here, there's our vertex. All right, now we just need to do like a little extra step, like what is actually P? Well, to get P, you just have to, solve for P, divide by 4. So P, the single P, is 2 because 8 divided by 4 is 2. So we have those 2 answers. But remember, the focal width is, let's put it in green. The focal width is indeed 8. The 2 part is just, I don't know why I went away, guys. Bear with me. The 2 is just the P, and we use that to find how much from the focus point, well, the vertex, how much up you go to get to the focus point and how much down you go to get to the directrix. So that's why we need P. All right, let's add this to our picture. So the distance from here to here all the way across is 4p. Nope, it's 8. I mean, it is 4p, but it's 8. And we're going to insert our distance from our vertex. So here's our vertex. So 2 up, and we're going to try to squeeze that in there. Ooh, is +2. And then going down to our directrix is -2. And directrix is our horizontal line right there. All right. Now, let's solve for these things, the focus and the directrix. Like, okay, you put a little dot there, but what is the value? So number 4, the next step is to actually find the focus. And I'm just put a little F for that. And the focus, you can think of it in 2 ways. Well, from the vertex, we went up 2. So 0 moving up 2 means we're going to do 0 + 2, which is just 0, 2. Or you can think of it in terms of, okay, what did we do from the picture? So you can think of it based on picture, visual idea, or a numerical. And that is our answer for that one. And then number 5, we want the directrix. And I'm just going to put a D for directrix. And it is the same idea. You can think of, what did we do? Well, we went down. So that's going to affect the Y value again. So it's 0, -2. And they're always opposites of each other. And when I say 0, -2, that's in terms of if it was a point. Directrix is an equation. So don't make that mistake. It's an equation. Y equals -2. And that is our answer. Or you can think of it again visually. Well, from the vertex, what did you do? You went down to -2, and that's a horizontal line. So that's a Y equals equation. And that is it. Ta-da! Hopefully it made sense.
5, you always want to start with a picture to get an idea of what's going on and whether you want a y equals or an x equals equation. So this is starting at 0, 0. Then they tell you it's opening down. And why do you think they're telling you your focal width?
Because we know that that's like 4p.
Yeah, so that like gives you 4p. So we know that this is 3 this way and 3 this way, but more importantly, that tells you 4p. All right, so again, if this is opening down, we're going to be able to do our general format. Again, we know we got A. We're going to make it negative because we're opening down. And then this is x minus h squared plus k. And like I said in the last problem, a lot of times I like to go ahead and rewrite that A as 1 over 4p. Because we know A, absolute value of A is equal to 1 over 4p. We throw in the negative there because we know it's opening down. All right, so then substitute in what you know. So 6 is our 4p. So we know that this is 1 over 6. And then our vertex is 0, 0 again. So we don't put in anything for h and k. So that is our equation. All right, let's scroll down to number 6. Focus at 0, -4, directrix at y equals 4. Ooh, this one's weird. It doesn't give us the vertex. So I think I'm going to definitely need a visual here. So focus at 0, -4. 1, 2, 3, 4. Directrix at +4. You know what's really cool about this? There's some symmetry.
Oh, they're p away on each side.
4 and 4,
Yeah.
so it's at 0.
Yeah, so if we are p away on each side, that sounds funny. But the point right in between is going to be your vertex. So our focus was here. Halfway in between is going to be your vertex. And the focus, as Miss Marshall kept saying repeatedly, has to be inside your parabola. So your parabola is going something like this. So what we have learned from our picture is that P has to equal 4 and that our parabola is opening down.
So we can find 4p then, huh?
Yes, we can. It's so amazing. So 4P is going to equal 16. Then I think you got enough information to write your equation. So it's opening down, so it's going to be a y equals. It's going to have a negative since it's opening down. And again, we know a is equal to 1 over 4p. So I'm going to write that as 1 over 4p. And then we've got x minus h squared plus k. Go ahead and substitute in what you know. So y equals -1. 4p is 16. And again, this is one that's at 0, 0. Lame. You don't need those parentheses there. I just start writing them because I think I'm going to put something with it. Prove that the graph of the following equation will be of a parabola. And then find the vertex, focus, and the directrix. So they basically want to know, how do you know that this is going to be a parabola? That basically means we need to put this into vertex form. So right now, you see these y values. You got a y squared and a y, but you only have one x. That kind of is a giveaway that this is a parabola, but we're going to go ahead and put this into vertex form. So we're going to put y squared plus 2y.
Wait, so do we got to complete the square?
Yes, ma'am.
Oh, Lord.
And really, if you're doing this, completing the square to make this in vertex form, we really only care about the y squared plus 2y part. So what I'm going to do is take half of 2, square it, and add that to both sides of my.
That wasn't that bad.
No. And then you're going to make this y plus 1. Once you factor y squared plus 2y plus 1, you get y plus 1 squared minus 6x plus 13 equals positive 1. Now, just like we were doing with the other ones, we actually want x on a side all by itself. So here's where it's a little bit messy. We can certainly bring the 1 over to this other side. So y plus 1 squared minus 6x and then plus 12. And then I'm going to put the 6x on the other side. Y plus 1 squared plus 12 equals 6x. And to get the x by itself, I'm going to divide everything by 6. So 6, 6. And dividing everything means I need to divide the understood 1 that's in front of these parentheses also by 6.
Not the inside of the parentheses.
Not the inside. So you get y plus 1 squared here, and then plus 2 equals x. So this is a parabola that's opening sideways. I'm going to go ahead and move the equals x over to the side that we like to have it on. So we get x equals. And then it says find all the stuff. Vertex, focus, and directrix. So your vertex is going to be at 2, -1. It is
because it's backwards.
Because backwards, yep. So this is going to be at 2, -1. And it's positive in front of that 1, 6. So this is going to be opening up. This does not say we have to.
Oh, no, it opens
to the
left
right.
or right.
Oh, we're having heart attacks.
Well, at least it stopped me that time. We are going to be opening to the right. And then it doesn't say that you have to make a graph of it. So it doesn't have to be as fancy as that last one that I screwed up. So P. So 6 is going to equal 4P. Right? So 6 divided by 4 equals P. So you get the 3/2 equals P. So 1.5, going 1.5 is going to give you your vertex. 1.5 the other way is going to give you your directrix. All right. So your focus is going to be at, and let's add 1.5 to 2. So 3.5, -1. Subtract 1.5, you get that your directrix is the line x equals 0.5. Is that all we have? Yes.
All right.
Right.
I think that's it.